I am Sivakumar, Assistant Professor of Mathematics. I am having 20 years of professional experience in engineering colleges. I would like to discuss what is mathematics today and what is engineering mathematics and what we require in order to understand engineering mathematics. All these three we are going to discuss, and followed by what is meant by real analysis, what is a complex analysis. What's the difference between real analysis and complex analysis, and what are prerequisites? All these things we are going to discuss. So first, let me tell you, this channel is Siva Discourse. If you like the video, you please subscribe and share the video. So coming to the point of mathematics, if you look at old dictionaries, mathematics as subject deals with three things: quantity, structure, space. But 300 years before, calculus has been introduced. So that is a change. So mathematics is a subject deals with quantity, structure, space and change. From childhood onwards, everybody studies mathematics. But in order to understand the mathematics and the subjects in the mathematics, we have to know all these four words. And all these four words are associated with the different subjects. Mathematical study of quantity is known as number theory. Mathematical study of structures is known as algebra. Mathematical study of space is known as geometry. Mathematical study of change is known as calculus. So, number theory, we are all familiar with the master in number theory. So, that none other than Srinivas Ramanujan. So, if you consider anything in the world, for example, human body is filled with flesh quantity, and we are having a skeleton that is called a structure. In order to maintain a shape, structure is required, and we occupy some space. So, and there is a continuous change between us and outside us. So, coming to this one, number theory and algebra, geometry, they have developed from ancient days. 300 years before, calculus has been introduced. So, before going to here, in order to understand what is a real analysis, what is a complex analysis, we have to understand the definition of calculus. I said mathematical study of change is calculus. What kind of change and what are the topics in the calculus that we see first? Coming to real valued functions. So that is known as real analysis. So here, four things we can say the main topics of calculus: how to find limit, how to find the limit of functions, limit of functions of single variable, limit of functions of two variables or several variables, or limit of complex functions. So we have to understand the definition of limit, and next one we have to understand when the function is continuous, and next one we have to understand when the function is said to be differentiable, and when the function is said to be integral. If we are discussing these four topics, limit, continuity, differentiability and integration for functions of single variable, means a function is defined from a subset of real number set to another subset of real number set. So we can generally call f from a to b, where a and b both are subsets of real number sets. I mean the elements in the both sets A and B are real numbers. Now the function is said to be real function, and if we are discussing these four topics, limit, continuity, differentiability and integration for functions of single variable, that is what we have studied from our childhood up to intermediate, which is known as a real analysis. Analyzing real functions. Coming to the engineering mathematics, here functions of two variables will be introduced and later on functions of several variables will be introduced. If we are discussing the same four concepts for even functions of two variables, say z is equals to f of x comma y, it is also a real function, but two independent variables, one dependent variable. So this is a function of two variables, and if you can understand what's the limit of functions of two variables or functions of single variable, we can able to understand what is the limit for complex functions. In the coming videos, I would like to discuss all these four topics: limit, continuity, differentiability and integration for complex functions. So in order to understand the analysis means these four topics, mainly these four topics. If we discuss for real functions, that's a real analysis. If we discuss these four topics for complex functions, that's a complex analysis. And one more thing we have to remember here, this continuity, differentiability, integration, all those are defined by means of limit. So there is a crucial role in order to understand the definition of limit. We all know that Socrates and Plato invented epsilon definition for limit for functions of single variable. So now let me explain what is the limit of functions of single variable y equal to f of x. Then we introduce the relation between continuity and differentiability. Then we will go for functions of two variables. Then we are going to discuss complex analysis introduction. So before going to see introduction for complex analysis, we have to understand the definition of limit for functions of single variable. Now we are going to discuss what is a real analysis. As we have discussed, analysis is nothing but analyzing real valued functions. And what kind of analysis we have to do for real functions means, for a real function, limit exists or not. That's the first thing we have to understand. And whether the given function is continuous or not. Second one, whether the given function is differentiable or not. Whether we can integrate the given function or not. Integrable, or we can integrate the given function or not. So these four, as we have discussed, all the continuity and differentiability and integration for functions of single variable depends on the definition of limit. So in this lecture, I would like to discuss what is the limit of function of single variable, and when limit exists, when limit does not exist. Limit of a function of single variable. We can write the definition of limit, epsilon definition of limit. For every epsilon greater than 0, there exists a delta greater than 0 such that modulus of f of x minus L less than epsilon. And graphically what it means, we know that a function of single variable, the domain set of values we take on x-axis and the range values we are going to take on y-axis. in order to draw the graph of a function of single variable. For example, if you consider a point A here, then to establish limit extends to A f of x. So here we have to understand what is extends to A. X tends to A means x is almost A. That's like we almost reached some place. Means we are not in that place. We are about to reach the place. Which means that x is different from A. X is close to A. X can be on the left side of A or right side of A. X can approach A either from left or from right, but it is near to A, it's not exactly A. For example, if we consider a limit x tends to 0, 1 by x. So if you draw the graph of 1 by x, y equal to 1 by x, if we try to draw x axis here and y axis, and so that's a hyperbola like this passing through 1 1, and if you consider x value is 2, it is half 3, 1 by 3 like that. Of course we are going to get the, if we take negative values, we are going to get this graph. Now if you consider a is positive or negative, let us here 0, at 0 we are trying to find the limit. At 0 minus, if you observe, the graph is approaching minus infinity. At 0 plus, if you observe, the graph is approaching plus infinity. Means here the function is taking jump from minus infinity to infinity all of a sudden at 0. Limit does not exist in this case. So the definition of limit is if some function is going like this and at a minus it is approaching some value L, and after a it is again starts from the same value, which means that at a minus whatever the function length here we have, at a plus the function length should be same, should start from the same value L. Then we say that limit x tends to a f of x is equals to this value L. Even though function does not exist at a, f of a minus is L, f of a plus is L, then we say that limit exists at x equals to a. Socrates is going to give a strip like this to his disciple Plato. This is a L, this radius is epsilon, of course this radius is also epsilon. I mean this line is nothing but y value here is L minus epsilon, and here the line is y equals to L plus epsilon. We know that a line parallel to x-axis is nothing but y equal to constant. Epsilon is negligibly small radius we can consider. Socrates will give this strip, and Plato has to get some strip like this with the delta radius, and this one we can consider x minus delta and a minus delta, x equal to a minus delta, and this one we consider x equal to a plus delta, and this vertical strip, the function should stay in this square, that is nothing but epsilon definition. For a given epsilon greater than 0, if we consider some horizontal strip, there exists a delta greater than 0, and if you can construct a vertical strip where function stays in that square, then we say that function has a limit at x is equals to a. That's a definition, epsilon definition, introduced by great philosophers, mathematicians, Socrates and Plato. After that, the definition of continuity for functions of real variables is introduced. Now, coming to the definition of continuity, if limit exists, coming to the definition of continuity, if limit exists but not but equal to function value, limit x tends to a, f of x is equals to f of a. Here we have to consider three conditions. First condition is limit x tends to a, f of x exists. limit exists for the function y equal to f of x at x equal to a. Means at a minus a plus the function attains the same value. And so I can draw the graph like this for continuity definition. X, y, let us say a point A here, and we consider some L here. At a minus, function is approaching L, this length, and after a also it is starting from L. I mean, if you just draw a line like this, at a minus it is approaching L, and at a plus it starts from L, which means that limit extends to f of x value is L. And at a, if we are having the function value is also L, then we say function is continuous at a. So 3 points I said, limit exists means at a minus a plus function attains same value. And second one is f of a exists and both must be equal. 3 things we have to consider. Limit exists, function value exists, both must be equal. Then we say function is continuous at a point. For example, same definition if we extend for the interval of points, then we say function is continuous on the interval. Now, here, if you observe f of a also exists means if that is different, for example, f of a is different, some value k, then function has the limit at x equal to a, function attains a value which is some value k, but function is not continuous. This is the case what we can consider is limit extends to a, f of x exists and f of a exists, both exist. Limit exists because limits end up with L value and start before a end up with L value, after a it starts with L, and at a the function value is different, it's not L, it's a k, both are different values. Then limit exists, function value exists, but both are not equal, both are different. Then function is having discontinuity at this point a. This kind of discontinuity is known as discontinuity of first kind or removable discontinuity. Why we call it as a removable discontinuity? We can change its function value from k to L. For example, f of a value is not k, f of a value is also L only. I mean, I can place this dot here, then the function is going to be continuous at a. Both are unequal, I mean, dot is here, discontinuity of first kind. If you change function value, f of a value, not k, if you change the function value k to L, I mean placing this dot here, we can make the function is continuous, that's why it is called removable discontinuity. Second type of discontinuity is, this is discontinuity of first kind. Discontinuity of first kind. Second type of discontinuity is limit does not exist. If limit does not exist, then this is the case. Limit does not exist. Best example where limit does not exist. Then function is discontinuous. I can draw another graph for it. For example, if we consider x-axis, y-axis, and let us consider a point A. The function starts from here and a minus it attains some value L, 1 say, and at a plus it starts from some other value L2. F of a minus is L1, f of a plus is L2, which means that function takes jump up as shown in the figure, or it may jump down. It takes jump via a. That's why it is called discontinuity of second kind or jump discontinuity. If function is continuous, simply we can say, if you just consider a function, start drawing the function like this without just lifting the pen, then that's a continuous definition. So that's about what is the limit and what is the continuity. In the coming lectures, I would like to discuss relation between continuity and differentiation and integration. Then we will move to the complex analysis series. One by one we are going to discuss what is a complex function and what is the limit of complex function, when the complex function is said to be continuous, when it is going to be differentiable, and what is the analyticity of complex functions, and followed by complex integration. So the topic of complex analysis maybe somehow seems to be difficult to draw the diagrams on the board, but we are trying to discuss one by one in detail in the coming lectures. Thank you so much.